Okay, for example 5, we're going to use the quotient rule. We're going to let y equal x squared plus x minus 2 over x cubed plus 6. Okay, so eventually we're going to find the derivative of this function, or this rational function, by using the quotient rule. So the first thing we need to do is identify which represents the function. So f is going to represent the numerator function, which is x squared plus x minus 2. And then we're going to let g represent the function x cubed plus 6. Okay, so again, keep in mind that this is going to represent the high. This is going to represent the low. Okay, so what we want to do is we want to therefore find the derivative, which is y prime. So using the formula, either using the prime notation or using our mnemonic, okay, we're going to take the low, which is x cubed plus 6, which represents g. So we have x cubed plus 6, and then times the derivative of the high, so therefore it's going to be d, the derivative with respect to x, of the function x squared plus x minus 2, and then minus, now we're going to take the high function, which is x squared plus x minus 2, and then multiply it by the derivative with respect to x of the low, which is x cubed plus 6. And then we're going to divide that by the low squared. So we're going to take x cubed plus 6, and then we're going to square it. So now let's take a derivative of the functions that we have in our numerator. So we have x cubed plus 6, and now we're going to find the derivative with respect to x of x squared plus x minus 2. So the derivative of x squared is 2x. The derivative of x is 1, and the derivative of minus 2 is going to be 0. So we get 2x plus 1. And then minus, we have x squared plus x minus 2. And if we take the derivative of x cubed plus 6, the derivative of x cubed is 3x squared, and the derivative of 6 is 0, all over x cubed plus 6 squared. Okay, now we can go ahead and then multiply these numerator out to simplify our numerator expression. So x cubed plus 6 times 2x plus 1, if we FOIL that, we end up getting 2x to the 4th power plus x cubed plus 12x plus 6. And then minus, we're going to distribute the 3x squared to get 3x to the 4th plus 3x squared minus, 3x cubed plus 3x cubed minus 6x squared divided by x cubed plus 6 squared. Okay, now we can go ahead and then combine like terms. So in our numerator, we end up getting 2x to the 4th plus x cubed plus 12x plus 6. We're going to distribute the minus sign to all three terms. So we get negative 3x to the 4th minus 3x cubed plus 6x squared divided by x cubed plus 6 squared. Okay, and then let's combine like terms in our numerator. So if we combine 2x to the fourth minus 3x to the fourth, then we get negative x to the fourth. And then we have x cubed minus 3x cubed, which is minus 2x cubed. And then we have plus 6x squared. And then plus 12x. And then plus 6. And then we divide that by x cubed plus 6 squared. And so therefore, this is the derivative of that rational function. Okay, now let's graph our function and our derivative on Desmos. So let's take a look at the function here. So the function that we have, the rational function, is parentheses, we have x squared plus x minus 2 divided by x cubed plus 6. Okay, so there is our function that we were given. Okay, and then the derivative function is the following. We have negative x to the fourth minus 2x cubed plus 6x squared plus 12x plus 6, and then we're dividing that by x cubed plus 6, and that is squared. Okay? Let's go ahead and expand this a little bit more so we can see what's happening with our graph. So here is what our graph looks like. Okay, so now let's kind of focus to see what's happening when we can see what's happening when it's near x is equal to negative 2. Well, we can see here that when y, in this case we know that this graph represents y, and we know that the red graph is y prime. So notice that when y grows rapidly here near x is equal to negative 2, we can see that y prime is also large here on both sides. And when y grows slowly, then y prime, you can see here, is actually near 0.